Welcome to your 13th day and the last day of the JS session. We'll be also doing some promises today. We'll kind of recall again what promises are, how to work with promises. We'll talk about some new things, again, related to promises, especially how to handle promise rejections. There's two ways, as you can see in the picture. There are kind of like two ways to do that and catch. And as you notice, there is a second argument. There is a second callback function for the dot then, and we never discussed that. So we'll also talk about that, and we'll kind of compare them. And last but definitely not least, we'll also talk about async await, because yeah, it's mostly async. It's mostly the async await syntax that we currently use when working with promises. I'm not saying that we don't do the dot catch or dot then anymore. Of course not. We do those. However, async await syntax is the kind of primary way of doing promises now. So so we started with when we started doing asynchronous things, we started with callbacks. Do we have a question online? Could you please mute yourself, whoever is not, or everyone, could you please mute yourself, whoever is not talking? Thanks. We have some background noise there. Okay, so when we started talking about asynchronous JavaScript, we started with callbacks, asynchronous callback functions, or asynchronous functions which accept callback functions and return the result of that asynchronous job in that callback function. As you recall, the agreement, the notation was that, well, let me just get that example, was that in JavaScript, starting in the Node.js world, the first argument is, okay, let me just set up the wrap again. Okay, so the agreement kind of, the notation is that the first argument of the callback function receives an error, right? If it's an error object, for example, if it's an instance of an error, like it can be whatever it is, but in this case, if it's an instance of an error class, then we have a real error which we need to handle. Otherwise, if we don't have an error, that's a null, indicating that the value of the argument error is null. Hence, we don't actually have an error, so there is nothing to process there, so no value. And in that case, we specify the kind of success values. Yeah, so that's basically the kind of asynchronous jobs with callbacks kind of style of doing. And as you have seen, it leads to a very bad place with what that we call the pyramid of doom, and then even some mental kind of issues, like callback hell, right? It's kind of hard to wrap your head around when or where these asynchronous things are being called, in which order. So what is being executed right, or what should be executed right now, so without running the code. So these kind of questions are getting hard to answer because the code is running in an asynchronous fashion. It's just kind of hard to, again, think about all that. So it's a whole nother mental model, hence the idea of the callback hell, because it just gets so complicated that it's kind of hell constructed of these callbacks. Yeah, and then we kind of slowly transitioned into the idea of promises, what promises are, and how to solve this issue. I mean, how to solve the issue with the pyramid of doom, and all the asynchronous stuff is still there. So very easily you can also get into the callback hell with promises too. You can very easily kind of do something like this with promises, as I've shown in the during the previous session, right? I was just nesting these dot thens into one another, and we've seen why that was unnecessary, etc. And so we've come to the conclusion that returning promises or values from the dot then functions was the correct way to do things, because you could keep your dot then kind of consumers and handlers on one kind of indentation. You would not have to indent them into one another. Also, if you would return a promise from a dot then if you would have a dot then after that, if you would have something like this, then you have then you have a guarantee that this value will be the kind of resolved value of the promise that was returned in the previous step. And if a normal value like an array, an object, string, number, whatever it is, not a promise, is returned, it is kind of simply passed to the argument of dot then. So sorry, not the argument of dot then, but the argument of the first argument of dot then, because now what we're going to learn today is that dot then actually accepts two arguments. The first one is the kind of success handler, right? Success kind of response handler, and the other one is rejection handler. So dot then accepts two arguments. So far, both of them functions. So far, we've talked about only the first one. We'll see what the second one does too. Now, as I said, if we return a promise from our dot then that promise will be awaited. We will be waiting for the promise to resolve, and then we will have its value. If it's a simple value like 1 or whatever, this value will simply pass to the kind of success handler of the dot then, will not be awaiting for anything. There is nothing else going on there, so it will just pass the value. So however, if we would write promise dot resolve 1, this would be slightly different. So we would have to kind of unwrap the number 1 from promise.resolve. As we know, promise.resolve returns a resolved promise itself. So we would have had to kind of unwrap like a New Year or Christmas present, right? So we would have to unwrap that promise to get the value 1. Okay, that's about, again, promises. And then we've learned a couple of interesting and useful, well, a few interesting and useful promise static methods, right? Static because they are available on the promise with the uppercase constructor. That's why I call them static, right? Because they are not available on the instance. So if we would create, if we would say new promise, right? I create a new instance of a promise. We do not have .all on there. We only have then, we only have catch, and then we have finally. So I'll also talk about finally if I remember about that. Okay, so what we've learned, we've learned a few static promise methods, right? The first one was promise.all, and what it does, it basically receives an array of promises. It then tries to resolve all the promises. If all the promises are successfully resolved, no matter if all of them are resolved in 1 second or in 10 minutes, doesn't matter. So if all of them are resolved, then we receive an array of values, or in the same order that we have our promises in the kind of argument of promise.all. So we'll receive an array of awaited values, right? Unwrapped values of these promises in .then as an array. So this is actually values. Let's also communicate that with the name of the variable. However, if any of the promises rejects, then the whole promise.all also rejects, and we will have that error in the .catch. Now, when you work with promises, it's kind of now imagine this part, right? This promise.all being returned from a function. Okay, so let's say this is my function. My function .then. So so what this basically should communicate to you is that my function returns a promise, hence we can do .then, .catch. Of course, we kind of just seeing this, we don't have a guarantee that it's a promise. We can simply return an object which has both then and catch methods, like something like this, right? So we can say then, and we can also say catch, right? And if we would return this object from my function, we would still conform this API. However, what I'm saying is that imagine we're trying to we're returning a promise. So what this function does, it should return a promise. Okay, so what we say, my function does some asynchronous job, and it returns the result of that asynchronous job, the values as a promise. Now, again, since this question came up during the homework, right, there was some kind of confusion that it was not clear in the requirements that the that one of the functions I asked you to implement should kind of reject with a promise. So what I'm trying to say, if my function returns a promise in the success case, right, it should also return a promise or reject in the worst case, because that would mean that my function will return a promise. That will mean that my function returns promise in the success case. So what do you think it should return for the failure case? Failure, should it return a number? Should it return a string? Should it return a null? Maybe it should return null. Maybe it should return undefined. Maybe if there's a problem, it should not return a promise, but it should return 3. I don't know. That depends on the problem that you're trying to solve at hand. However, what I'm trying to say is usually you should kind of try to keep the API of your functions as similar to each other as possible. So, for example, in this case, in the success case, we're returning a promise. So in the failure, in case of a failure, you should also return a promise. However, that promise should be rejected, so that you can. If you can do .then on the success case, you should be able to do .catch on the failure case too, right? If you would do .catch and that would break, right, because you are returning 3 and you can do .catch on 3, that would be actually really unexpected by any programmer, right? Any developer will just raise their eyebrows, like what kind of interesting thing is going on here. So even if the problem statement doesn't say in case like your argument validation does not pass, throw an error or reject your promise. Even if it doesn't say that, but it says return a sum of numbers in a promise. Now, if the type of your arguments is not numbers, right? So one of them is not a number. You should kind of take care of such cases yourself, and then it should be intuitive for you to do the validation. And when the validation fails, since you are returning in your success case, you are returning a promise, you should also return a promise in the failure case, because you are communicating something with someone to your user actually, because you as a developer, and now you are a developer, okay? I know that it's kind of hard to kind of combine all the QA mindset. I've seen this during this course. It's kind of hard to step back and think outside of the QA mindset and think about the problem as a programmer. However, again, this is not like project requirements. Okay, if it's not specified, then we should not do this. No, it's not that at all. It's kind of development, kind of intuition and logic. So if your function, if the sum of your function returns, if your function returns a sum of two numbers, right? Now, of course, in this success case, the result is a number. However, depending on the problem statement or the task at hand, sometimes it makes sense to throw an error if your validation of your arguments does not pass your criteria, or you know, if nothing is specified, it makes sense to return NaN. Okay, so not a number. So saying I just cannot add up these two numbers, it's an NaN. So there are different ways to think about this. However, again, try to keep the APIs, and when I say APIs is the here I mean the output. So try to keep the output of your functions as similar in both success and failure cases as possible. So, for example, let's imagine we have another function, right, and which returns an array of elements. Okay, so and imagine we're checking for something. If that thing is true, then return an array of elements. But what if that thing is not true? I'm not even kind of giving you a very specific example, but if someone would tell me something like that, my first impression would be else return an empty array. Okay, why? Because at least my user, another developer, or myself who will be using that function, know that that function always returns an array. So they can always do dot length on there to check if the return value is empty or is not, and then do their logic on top of that. Of course, I could also, I don't know, throw an error if on the else case, right? If the condition is false, just blow the function, throw an error, and that's it. Okay. In that way, I would keep my API or application program. Well, it's of course not a real kind of API, but I'm just calling it an API. So I would just keep the returning type. Let's put it this way. I would keep the returning type of a function the same as much as possible. Sometimes it is stated in the problem directly that you should throw an error, or you should do this, not that. So you do that, not this. So in these cases, of course, you kind of follow the problem statement. However, if it's not stated, you should try to keep your return value as similar, the same. Okay, if possible. Yeah. So one other interesting thing could be for example, the find index function on the string, right? So, I'm talking about this. Let me just roll back all these changes here. So what I'm talking is this one. So I can do find index. I hope I can do that. Can I console log this? Oh, sorry, index of find index. What type of programming language I was thinking of? Console.log. And can I not do, what is this? An argument that says, oh, of course. So let me see. Let's maybe see the index of E. Okay, so the index of letter E is 3, which is correct because 0, 1, 2, 3. Now that's correct. Now, what if I would get the index of R? It's 1. That is also correct. And I could get the index of the last A, right? So I can also do that. But what if I would like to get the index of letter B, which is not in this string at all? So it gives me -1. Now, why does it give me -1? It could give me false. It could throw an error, right? It would say the letter we are trying to look up in this string is not found. So it could return a rejected promise, right? Why not? So it could return, I don't know, undefined, null, any kind of some empty string, some kind of falsy value that I could identify, right? So if I would say if dot index of, right? If the value is falsy, do something like this. If it's not, then do this. But no, it returns -1. But why does it return -1? Because in this success case, what we do, we return a number. Hence, to keep the returning type the same, to communicate to the person who is using this function index of that, hey, in the success case, we are going to return you the actual index of that letter in the string. But if we don't find that letter in the string, we're going to return -1. Why? Because so you know that you will always get a number as the result of index of. So you can do your calculations, you can do your checks, whatever it is. So you don't have to memorize, okay, so what happens if my letter is not found? Now, since the returning type is the same, it's a number, the only thing that you memorize is that the actual value is -1. And in JavaScript, they kind of keep this try to keep this consistent. It's also the same thing. I think for the arrays, the function was find index. Yeah, I think it was find index for the arrays, and they also kind of do the same, right? It's an array method. Let me actually check. I don't recall that array method that well. Don't use it too much. So 1, 2, 3. Find index. Now, as you can see, even in the documentation, okay, so this is the returning type of our array method find index, and we have the documentation. So this is Visual Studio Code again helping me out, so I don't have to go to MDN, whatever it is, to see how this function works. Now let's read this one line. It says find index returns the index of the first element in the array where the predicate, meaning the predicate is this function, is the argument of find index. So where predicate is true. So for example, in this case, find index, the predicate would be element equals to true. So the predicate in our case is this function. So that's what predicate is. Okay. So again, let's read it again. So it says return the index of the first element in the array where predicate is true and -1 otherwise. Can you see they even try to keep this consistent with arrays? Because when you learned this index of with strings, now you know it's index -1 otherwise. Okay. So you already know this syntax. You already know this kind of convention. You know that index of either returns the index of the matched kind of character, or it returns -1. Now, I can just copy paste this there, and this is an array method. This is not a string method, and this statement is still true, because if your predicate returns true, if our element equals to true, right? This one, if our element equals to true, then we return it in its index, which is 1, hence the value 1 in terminal on the right side. Now, again, this statement is very true. Now, if I would say, find me return the index of the element, which the value of which is 6. Now it will say -1. Now this is the same API, okay? Again, so that you know that whatever you get from find index is a number. The value is -1. It's used that -1 kind of notation is used, convention is used throughout, like these native APIs, etc. Maybe there are some other places in JavaScript, I mean native functions which return -1, but both of these are the kind of ones that I can recall right now. And again, as you can see, one of them works on strings, the other one works on arrays. However, the result that they give you is very similar because both of them are trying to return you an index. And if the index of the element, whether it's a letter or whatever you're trying to do with an array, is not found, they give you a -1 so that you know the API, the look of the output, the return type of the output is the same. So you don't have to learn how index of works, what was the returning type. Okay, now this is find index. Imagine find index works completely differently, and you would have to learn much more stuff. Again, this is for simplicity. It just makes logical sense to do this. And also in your code, and now I'm like really spending lots of time on this, but this is very important. Okay, so today's topic was promises, and then I kind of went into the function the function return value type kind of land. So sorry about that, but I feel this is an important topic to talk about. Okay. Cool. So yeah, I've received your homework. Whoever sent me the homework, good job. So this coffee shop, this was slightly kind of a longer one, but I would not expect that this would be hard or something like that. It's just slightly more maybe time consuming to implement this. So whoever sent your homework, good job. Yeah, so that's about that. And without further ado, okay, let's continue with promises. Now let's go with catch and the second argument of then. Okay, well, we've already seen how promises work, what promises are, so we can continue with this. Okay, now, given there are two ways of handling kind of errors with promises, right? Kind of catching these errors. Now you might think, why do we even kind of really need to have two ways, right? So let's have a rejected promise. Why not? Let's start with that. So since we're talking about catching errors, etc., so we're not going to really need a result promise right now. So I'll go with a rejected promise, and of course I can do dot catch on that, and I will say error value here. Okay, and I'll do console dot error and error value. Okay, so it just console logged 5, which is expected. Now let me maybe console this. Comment this out, comment that line out, and let's go for a dot then. What I'm going to do, I'm going to say I have value. Let's console dot log that value. Now, of course, nothing is being logged. That's normal because again, promise.reject creates a rejected promise, right? If you recall, we have two states of promises. I mean, set of promises. When we create a promise, its state is pending. So that would be the third state, right? The initial state of promise is pending. And when we consume our promise, it either becomes kind of no, sorry, then it can become kind of resolved in the officials, like the name of the state of a result promise is fulfilled. So the state would then transition to either fulfilled or rejected. So when we say promise.reject, we create a promise which is like directly rejected. So the state of the promise is rejected. So it cannot then become resolved or fulfilled anymore. So that's why this dot then will never work. And hence we have this unhandled promise rejection error in the terminal. Now, what if then I specify the second value in our dot then second handler? Now, as you can see, this works. Okay. Now, what if I just remove this first one? But of course, since this is function arguments, not array destruction, I cannot just delete or remove that part. I would have to still kind of provide an argument. So I will say null. Now, basically what dot catch is, it is this. So it is the dot then where the first argument, the result or fulfilled value handler is null, and the second handler is not null. It's a function. So both of these are basically the same. But then if these are the same, then why would we just need this dot catch? Then what is basically the difference between, you know, using this or using this? Now let's remove this dot catch. Okay. So now what I'm going to do, now I'm going to switch to a resolve promise, resolve. And I'll say value console log success value, and then what I'm going to do is I'm going to say throw new error, hello error. Okay, fair enough. So what I'm doing here is I am creating a result promise, right? The state of this promise will be fulfilled immediately because we're using promise.resolve. And since this is a resolve promise, of course, this dot then will work because it's a fulfilled promise. And of course, we know that at least this first function will be called, which is logical. We know it works. I can tell that without running this code. So as well as you can do so. So okay, then what we do, we throw an error, right? I'm trying to kind of simulate a hypothetical case where in your dot then handler, in the success handler of dot then, we occur some kind of runtime error, whatever it is. We are writing code, right? So that code is not 100% like error proof, right? So we can make mistakes, or the incoming data might have some different shape than we expected, and we might accidentally occur some kind of errors which we did not anticipate it for, but anyways, whatever it is. So I'm trying to simulate an error here, and luckily we provided this second argument, right? So if there are any kind of errors in here, we will kind of handle them. That's why we have the second argument. That's the kind of whole purpose of the second argument. So I'm a happy developer since I've catched the error, so I'm going to save this. Cool. So what I've done here is I've logged the success value 5, and then we have our error. Okay. So what I'm going to also do here is I'm going to say hello, or rather dot then error. Cool. Okay, but that was strange. Wait a second. Did you notice what happened? I said console error .then error, an error value, but I don't see the .then error here. Like, okay, maybe I'm doing something wrong. Let me see. Oh, okay, I changed console log. This doesn't work. This is really strange. Now, again, we're coming to the idea why we actually need .catch and what is the difference between, the first argument, what is the difference between having a .catch and having this .then, null, and the rejection handler, right? So now we're coming to a realization that our error was not actually catched in this second kind of error handler, but we do have an error handler. Why is the error not handled there? Again, as you can see, our success value is logged, right? This console logged worked. However, the second one strangely did not, because we don't see this .then error. So the error just goes somewhere. We don't know. We didn't catch it. We didn't do anything with it. Otherwise, we would see this .then error and then the error logged in the terminal. But however many times I save this file, we will never see it. Now, the problem with this second rejection handler kind of function in the .then is, if any kind of error occurs in your success handler, that will never be catched by this, okay? However, if your promise was rejected, that would be okay. Yeah, we would catch that with this second error handler. As you can see here, .then error is 5, which is expected. However, again, when an error occurs not in the promise itself, but the success handler, the first argument of .then, right? So imagine we have some kind of runtime error, like, again, I brought a couple of examples here. We're writing code, we're people, we're humans, we're making mistakes or whatever it is, or the data comes in a completely different shape. We didn't expect this. It was not communicated to us. Project, I don't know, requirements were wrong. It was not mentioned in there. So we should contact whoever it is to fix that. However, we have an error at hand, right? So again, the problem with this first handler is that whenever any error is thrown there, the second argument of .then will not catch it. That's when you will have to have a .catch after that and say error console error. Hey there. Okay, I'm just typing some strings before and after the error so that we can see that we're actually kind of logging things. As you can see, hey there is here. And this is our error, right? And hey there is there. So basically, we catched that uncatched error, which was thrown in the first argument of .then, because it was not catched by the second argument of .then. So be very careful when using this rejection handler, right? How do they? Yeah, they called onRejected, the onRejected parameter, the second argument. So the first they call, like the docs, it says onFulfilled the first one and onRejected the second one. So be very careful when using this onFulfilled argument, which is the second argument of .then, and instead aim to use this .catch, right? So again, to avoid these cases when an error is thrown in the onFulfilled handler and you will never catch it in the onRejected handler of that same .then, you will have to use .catch, and I guess you will able also do this null error thing. It's kind of, again, the same thing. So again, whatever error handler you have afterwards, that will catch it, right? Both then null error. This will also the second on rejection handler of the second .then will catch it, because the error occurred in a previous .10, right? So if I instead of this null, I would write another function and throw an error there. The second one wouldn't catch it. So I would have to have another handler after this .10, which would be able to catch that error. So be very careful with error handling. Now there is something, or I think not nowadays, but in early days of promises, there was something called, swallowing promise rejections, which meant if you would not do any kind of error handling on your promises, and there would be actually an error in your promise, it would just silently go away. Okay, so you would never be notified that there is an error, right? Never. The engine would not let you know that there is an error in your promise, something went wrong, and you would never be able to handle it. So they added some workarounds in Node.js and I think in a V8 engine, which is used in Chrome, and in other engines too. They added some workarounds to kind of globally catch all kind of errors, right? So I think if I would do this, how do I get this unhandled promise rejection? Yeah, so they added these ways to handle all these unhandled promise rejections. So they added some kind of global interceptors, that kind of stuff, some things that you can provide your functions to, and they will basically catch all kind of global promise unhandled rejections, etc. So they had these workarounds, and then they basically changed the behavior of how unhandled promise rejections work. So previously, well, in the beginning, if these errors were just being swallowed, so you would never be notified. So they would just silently go in your application, and you would never be notified that there something wrong happened with your promise. They actually completely changed the behavior. They did a 180-degree turn there, and they actually started terminating your program when there is an unhandled promise rejection, right? So in your usual programs, if you would do for example, throw one. Now, this program is kind of terminated program. If we would not be running in this development environment that I am, the program would just stop, the process would be killed. So you would have to start your whole application again, etc. So this is how kind of throw works. If you do not handle this with try catch statements, it would just completely kill your application. And so they changed the behavior of unhandled rejected promises to be kind of the same. That was a big turn, because previously these promises were simply kind of swallowed by the engine, and they were kind of silent rejections. But now they changed that your program kind of dies or terminates completely if there is a promise rejection. Yeah, however, that's a couple of words about the history of handling with promise rejections there. Okay. Also, if you recall, in I think it was not the last session, but maybe the first one, maybe the last one. Let me go to these promises. Oh yeah, it was the previous one. So if you recall, what I recommended was to have this dot catch in as kind of the last handler in your chain. Actually, I was saying this having in mind that I was going to get into this on fulfilled and on rejected dot then kind of arguments, etc. So again, it's you shouldn't be really doing the second, you shouldn't be really using the second argument of dot then to handle any errors of the first argument of .then, you should be using a .catch on the end of the chain, etc. Because again, if you put in a catch consumer in the very end of your chain of promises, right? We have a chain of promises here. Okay, so each .then, if we return something, even if we don't return explicitly something from .then, that would return a promise which resolves to undefined. So this is basically a chain of promises. Even catch, you can do a return in catch too. So this is a chain of promises again, and since I'm interested in just handling any errors, I put my I have a kind of a global to this chain, global, right? So I have a catch consumer in the very end of the chain. So any error that occurs in the middle or whatever it is in this chain will be catched. And also, if you noticed, I have another .catch handler after the first one, because here I was interested in handling the errors of these two promises specifically. And then what I do, I rethrow my error, right? Since this is an error, if I would not throw this error, we would continue with .then. We have seen this. Hence, we have to throw this error or rethrow the error, like continue passing the error in the error chain. And that way we will get to this last .catch, and then we'll handle our errors there. So again, error handling is a very interesting topic. It's also a very important topic, because if you don't think about handling your errors, your application is not going to be too stable. It's going to fail. I'm not talking about bugs right now. Okay, I'm not saying that you shouldn't be leaving bugs. Everybody leaves bugs. Doesn't matter the seniority level. That's not what I'm talking about. But you should be thinking about handling errors as much as possible, because again, if you do not handle any errors, that will really lead to a very unstable product and horrible user experience, etc., etc. So again, very important topics here to learn how to handle rejected promises and stuff like that. Okay, now let me see if we have anything in the chat. We don't, and not in here too. Cool. So in that case, let's do 10 minutes of break, and then I will quickly introduce the async await syntax. And since this is the last day, I'll dedicate like 10 to 15 minutes at the end of the session for I don't know, a Q&A, or if you have any questions, go ahead. So that will be that. And just to let you know, I wrote that in the channel. We'll be finishing the call 5 minutes earlier, so I'll make a hard stop at 11:55. And if any one of you is in the Erebuni meeting room, you should also free the meeting room, because there is a meeting in the Erebuni meeting room at 12 o'clock. So that's about that. Okay, let's go for a 10-minute break. So let me resume the recording. Okay, so the last topic for today is the async await syntax and how to use that with promises. Again, a very important syntax. We actually borrowed this from C# because they also do have async await there. I mean, they do have the async await syntax there. I think in C#, the kind of analog to promises are so-called tasks, if I'm not mistaken. So you could do this async awaiting on these tasks. Yeah, so let's see what this async await syntax is and how to use that. Now, we've learned about functions, okay? So we basically know what functions are. We know they receive some inputs, they give you some outputs. Now they have added this async await syntax to make working with promises kind of easier, to make it work, to make it look like you're doing like your asynchronous code looks like synchronous one, and you will see in a moment what I mean with that. Right, so let's maybe start with the actual syntax of async await and see how that works. Let's have a function, okay? Function do work, and let's maybe return I am doing some now. Okay, so when I call this function do work, of course I will see nothing because I'll need to console log the result. Now, when I do the console.log, okay, so when I do the console.log, I will see this, I'm doing some work right now, string being logged in the terminal. Okay, what if I would like to return this string as a promise? Well, now we're working with promises, so for some reason, I'm interested in returning this string as a promise. So what I do is I can say promise.resolve, right? And now what is logged is our promise. Now, however, I can do this also with other way, of course. I can say, now create me a function which does something asynchronous. The name of the function is do work. It does not kind of receive any arguments, and it returns a string. However, we now see, as we see, it does not actually return a string. It returns a promise. Did you see the last console.log? Right, let me say now one, right, now one. And if I now go back to the string version and I say async and save it, now remember it says I'm doing some work right now, and there is one appending to the word now. So now when I save, did you see the one went away, and we still return a promise of our string. So async await is kind of a coin which has two sides. So one side of the coin is the keyword async, and you use the async keyword with your functions. Now, this is how you use your async keyword with normal function declaration. You can also use it with an arrow function. Do something else. Okay, so the way I use it, I say async and then my kind of function expression, and I say return 1. And now when I console log my second function, now it will say promise 1. So why I started with the async keyword, to simply show you that async functions always return promises. The only return type of an async function is a promise, always. So let me return null here. It will say promise null. Let's not return anything explicitly. It returns undefined. Let me return an object. It returns a promise which resolves to an empty object. Let's return an array. Returns an array. Let's return nested arrays to another nested array. It will return all of them in a promise. So again, this is why I started with the async keyword, and this this, well, I would have started with the async keyword anyways, but I started with this simple example to simply show you that async functions always return promises. That's one thing you should know by heart, and you should learn about async functions. They always return promises. Now, in that sense, you can, of course, do promise.resolve, of course. And as you can see now, we have this promise and it says pending. Why? Because we have a pending promise inside a promise. Now, what we have to do here is we have to do, let's say, do work. Let me remove this part. Do work dot then value console.log value. Now we get this. We get our string. Now, what if I remove this promise.resolve? I just save the file, and as you can see, we still get our string. So we know that async function always returns a promise. We have seen, let me console log it again. We have seen that an async function which returns an actual promise, like here, because we return promise.resolve, it returns a promise which contains a promise, hence this pending, right? Now, the way to consume a pending promise, the way to consume your promise is to write .then on it, okay? So I wrote this .then consumer, and I have the value. But interestingly, when I remove this promise.resolve, the value is basically still the same. Now, in this case, we have now our async function returns a promise which contains the string directly instead of containing a promise which contains the string. So, but in both these cases, the lines 15 and 16 never changed, right? See, so the .then was still there. So in one case, it was promise contains a promise which contains the string, right? This was one case. And the second case is the promise directly contained the string. Okay, now in both of these cases, this code was the same. So .then worked. Now I'm talking about very specific example here with async function. Okay, what I'm talking about is returning values from async functions. So I don't want you to kind of think that if there are well, okay, so I'm not going to say that because that will just complicate everything. So let's keep that part. Okay, so we have our async function. It returns a promise, always, we know, we've seen that. Now we're returning promise.resolve. So interestingly, the way this then works, it kind of, as you can see, it kind of tries to unwrap our promises, right? So this is the first layer, this is the second layer, and then we come to, then we kind of get our actual value. In the second case, there is our promise, which contains our value directly. So we unwrap the promise only one time. So with this .then, we're kind of doing this unwrapping, or the engine is doing this unwrapping for ourselves. But in case we return promise, it's kind of two layers. In case we return a value, that's only one layer. So of course you can do this, right? But you can also just return your value. Now, if we're doing some async, right? So we can say number one, number two. Let's imagine we have a guarantee that our numbers are always numbers. So the arguments are of type numbers. So I will not do any kind of validation here. So what I can say 2 plus 2. Let's see what 2 plus 2 is. Okay. 2 plus 2 is 4. So again, the sum of 2 and 2 is 4, and we receive, and the return value of our sum async is a promise, which contains the actual kind of addition of two numbers. And in the line, on the line 13, we console logged the result of sum async, which, as we can see, is a promise. And on line 16, we log the actual value. Now, of course, again, I can go ahead and do these promise.resolve. And again, on line 13, we have a promise which contains a pending promise, which contains the sum of our numbers. So the first case, and this dot then is basically unwrapping all these promises to get to the actual value, okay, to get to the end. So it continues kind of to unwrap everything until it gets to the value, or one of the promises just rejects. And if one of the promises rejects, of course, we will be in the dot catch consumer then. Okay, so again, what I'm trying to say here, or what I'm trying to show here, first, async functions always return promises. Second, if possible, try not to return promises from your async functions. Of course, you in your .then consumers, you will still get your actual values, but it's an unnecessary step here. Okay, so for example, on line 10, I returned a promise.resolve. If this would have been a normal function, and if I would need to return a promise from a normal function, of course, I would have to create this promise somehow. And promise.resolve is the kind of short and correct way to create a resolve promise. So I would use promise.resolve here for sure. But I could also do an async function. I could also mark the sum async function with the async keyword and simply remove this promise.resolve, and the functionality there wouldn't change. It's basically kind of the same thing. However, well, in that regard, the result is the same thing. However, using the async keyword, enables us to use the await keyword too. Now let's write another function, another async function. Okay, async, right, function, log result. Let's see, a log result of addition. Okay, now I'm also going to get these two numbers just for the sake of this example. And what I'm going to do, I am going to create our sum. Let me actually just copy paste this part, and I will just comment this out. Now, the whole purpose of this log result of addition is to simply do console log of the sum of two numbers. Okay, so what I do, I provide this num1 and num2 into our sum async, and of course sum async then adds these numbers together. Since it's an async function, it returns a promise, hence I do a dot then there, and of course I don't return anything explicitly, or so indirectly I will be returning an undefined, but no, I will not be returning an undefined. I will actually return a promise, and the result value of that promise is undefined. Why? Because we marked our function log result of addition as an asynchronous function. Hence, it will return a promise. As we know, async functions always return promises. So maybe let's call this log result addition 3 and 5, whatever. We should see 8 in the terminal, and we do see it. Okay. However, as you can see, we used our dot then here, and I think we can do better here. Now we're coming to the second. We're about to see the second kind of side of the coin. Okay, so let's do it this way. Let me store the result of this sum of numbers. Okay, now now the result of sum async is a promise, and I've created a variable called sum of numbers, and I assigned the returning value of the function sum async to that variable. So now even TypeScript can kind of indirectly infer that the type of my variable sum of numbers is a promise. Okay, so we know it's a promise. Wouldn't it be cool if I would say this? If I could do something like this, and it would actually just log 8. Now, of course, it will not log 8. It will say this is a promise, and the result value of that promise is 8. That's what I will see in terminal. But it would just be so cool if I could just log 8 this way, and just notice how kind of synchronous this code looks like, right? So what I say add two numbers together, assign the result of that addition into the sum of numbers variable, and then log it. I'm kind of trying to dream about this code running that way, but it's not going to run that way because sum async returns a promise. We are in the asynchronous world, so it's not going to really kind of work that way, and the returning value of sum async is actually a promise, not a value. So I can do it this way. Now what I can do is to use the await keyword. Now when I say await on this, now what this basically means, when I say await a sum async num1 num2, means kind of, do this unwrapping on line 26 or 27. If you remember, we're doing some unwrapping with the dot then. This await basically does the unwrapping there on line 14 of the result of sum async, and the actual value of the sum numbers then will be the number 8, but not promise, as you can see here. So basically this await is kind of similar to, doing the dot then. Okay, so when we did the dot then, we had the value, then we could do the console.log value. Okay, so basically these two lines is kind of similar to these. However, these two lines look kind of too similar to the synchronous code, right? Because if both of these functions wouldn't be, I don't know, asynchronous functions, if they would not return promises, but just simply numbers, this will still work. Okay, so what I did, I simply removed the async and await keywords. Now, if I start adding the async keyword, I say async, so I mark the sum async function as async. As you can see, immediately I'm logging a promise. Now let's. The solution here is to our solution here is to use the await keyword, right? So let's try to use it. But no, you cannot use the await keyword alone. Hence, I brought the analogy of the coin. The coin has two sides. Like you cannot have the one side without the other. So as you can see here, we have an error. This is a syntax error, and await expression. It says that await expressions are only allowed within async functions. Blah blah blah. The rest of that sentence does not concern us. So what this basically means, we can use the await keyword only in async functions. Okay. So to be able to use that await keyword, I mark my function log result of addition as an async function, and now I can use it. Now, if we would just again remove these async keywords and the await keyword, this would be our exact synchronous code that would just log the addition of 3 and 5, which is 8, and I'm bringing back the async await. As you can see, pretty much nothing else changes, only the async await keyword. And now you can see how similar this is to the synchronous code. Okay, so now we have an asynchronous jobs, asynchronous functions doing asynchronous stuff. However, we wrote our code like it's asynchronous. So this is the whole power of async await syntax, because you are writing your asynchronous code like it's a synchronous one, but it is actually asynchronous. So this async await, again, this async await syntax gives you the power to write your asynchronous code like a synchronous one. So your code, your asynchronous code looks like synchronous one. However, it is actually asynchronous. That is why it's a completely new syntax. You cannot kind of mock it. So this is a new syntax which enables our JavaScript applications and scripts and programs to do all this nice stuff. And async await syntax is actually a way to basically work with promises. Okay, so again, since our async functions return promises, then the whole kind of async await thing is based on the promises. Okay, so when I say asynchronous, we should imagine that we're talking about promises here. Now, okay, so what if I say await 3? Can I do something like that? So I'm calling my log result of addition, and I modified the line 14. Now I say const sum of numbers equals to, not equals to, sorry, but I say assign the value of expression await 3 into the variable sum of numbers, and then console log that. And this will work. So you can await on your normal values. Now, of course, we usually do not write something like this, but what I'm trying to say, if you have variable const hello, which holds a normal number, not a promise itself, this is okay. This works. So you can kind of dynamically calculate some kind of value. If that value is a promise, we will be unwrapping all these layers of promises to get to the actual value. If it is an actual value, then much like the way the dot then works, which whenever we're returning a value which is not a promise, it simply passes that value to the next dot then, etc. So it kind of works the same way here. So we can do that. Now, okay. Now, what if something goes wrong in our in one of our asynchronous functions? So I'm intentionally throwing an error in our asynchronous function sum async to just kind of simulate a bad case. Now, again, I'm not changing this part. Let's save the file and see what happens. And we have an error, an error thrown here, which is not cached. Nobody cached that error. Nobody handled that error. So an unhandled error execution here. Okay, so how do we then handle these kind of error cases with async await? Now, with normal promises, we know that we can use the .catch consumer in the promise chain to handle our errors. So how do we do that with async await? Now, remember when I said that async await kind of syntax allows you to write asynchronous code like a synchronous one? And how do you handle your errors in your normal synchronous code? with try-catch statements. So you can do it. You can do it very well also here. So what I will do, I will say let sum of numbers equals to 0 initially, and I'll remove this part. Then I will have my try and this code and catch error. So dot this, sorry, this is handled rejection, and I will say error. Okay, and I will put this console log in here. So let me save it, and as you can see in the terminal, we have this string, right? Text. This is a handled promise rejection error hello. So now this is how you handle your promise rejections with async awaits. Okay, so you can use the same try, catch, finally blocks with async await that you would normally use with your synchronous code, right? So if I would just remove this async and await here, notice everything stays exactly the same. So we still have this is a handled promise rejection, and we see our error log in the terminal. So this is a perfectly synchronous code, no asynchronous stuff going on here, not at all. Now I'm bringing back the await keyword and the two async keywords, saving the file, absolutely the same. So again, this is the power of the async await syntax. Not only you write your asynchronous code like it's a synchronous code, but you can also use the try, catch, finally blocks to handle your errors. So again, from the old callback hell, and this is how you solve, by the way, this is the solution of callback hells, because there is nothing kind of strange and no new mental model to adopt here. You are reading your code from top to bottom, and it kind of to you, it will execute also this way. Of course, everything in there works asynchronously. However, that complexity is now removed from you. So you are now removed from that complexity of asynchronous code execution, and what your code looks like. It looks like it's a synchronous code. However, we're doing async await, which means this is not not a synchronous code. We're working with promises here. Promises are asynchronous. Promises, yeah, that's the kind of promises are units which represent some asynchronous job. So it's not about doing synchronous things with promises. So this is asynchronous. However, your code looks like it's doing something synchronous. Now, again, if I would remove this async and await keywords, this is a perfectly looking synchronous code. And when I would remove this async, now this is a perfect synchronous code. I mean, in not perfect code, but I mean, synchronous code. Okay, so no asynchronous stuff going on here. This is a synchronous code. It's a perfectly synchronous code, not perfect code whatsoever. So, okay. So that's that. Okay, so I think I've covered everything I wanted to cover today. Let me just check at the image. So we've talked about .catch, .then, I mean the rejected argument of .then, and then we also covered async await syntax. Now again, it's as simple as it looks. Let's also try another example. Okay. Let me very quickly create that sleep function, right? I'm going to, create a sleep And notice that I'm not going to mark this function as async. So I'm going to return, what happened there? Nowhere. Okay, so promise and R and set timeout. Let's call this R. If you are wondering what's going on here, then you did not do your homework. Timeout and this. Okay, let's keep it undefined so it does not bother us. Okay. Yeah, so we've created our sleep function. Now this function returns a promise. However, it's not marked with the async function. Okay. Cool. So now what I'm going to do, I'm going to create an asynchronous function, main. Now what I'm going to do here, I'm going to await for 3 seconds. Sleep for 3000 milliseconds. Now I'm going to say console log, just waited for 3 seconds. And I'm going to also sleep for another 2 seconds and console log 2 plus 5. Let's save this file and see what it does. Let me also clear the terminal, save. Now, we're waiting for something. So we have our kind of timeout. We should be having our timeout going, but of course it will never go because we did not call our function. Now I will explain what will happen and then we will invoke the function itself. So what I've done on line 36, I've created or recreated the sleep function that we already kind of re-implemented a couple of times. I don't have any validations for the timeout. I don't care about that because I will be using this function, so I know I'll supply the correct value always in this case. So I just recreated that sleep function. This is not it is not part of the native JavaScript kind of library, so I need to create it myself, and I did that. Now, for the purpose of this example, now I've created an asynchronous function to be able to use the await keyword. My purpose here is to use the await keyword. Now, what I do here is I sleep for 3 seconds. Now, again, remember that this sleep function is not marked with the async keyword. However, it returns a promise. Actually, it doesn't matter what it returns. Unless it returns something, we can await it. As we've seen, we can await promises, we can await normal values like, sorry, like strings, numbers, whatever it is, and await will return that value, right? If it's a promise, it will keep unwrapping these layers of promises until it gets to the actual value. So what we do here is we sleep. Now, the normal way we would use this sleep, we would say sleep, invoke that function, and then .then, and once we're in .then, we would know that that the timeout has passed. Now, can you see how convenient it is to use await? Now, we're not assigning the value of this await to anything. Now, what await does, it simply kind of makes this promise to resolve, right? So it kind of tries to consume this promise. So when we're on line 39 and 40, imagine we're in the .then of this sleep. So if we would write this code with the .then, it would be sleep invoke with 3000 .then blah blah blah, and we would need to code, and we would need to write our code in the .then. But instead, we use this async await syntax, and instead of doing the .then and nesting our stuff in the .then, we simply say await. Now, when we say await, we will try to wait for the resolved value, right? So we will try to, if the promise is resolved, that's when we will complete, then this await will kind of complete successfully. If our promise rejects, we would need to use the try catch block, and we would be in the catch block. But in this case, it will not throw because we're just using some set timeout, and we always resolve our promise there, so no problems. So on line 38, we wait for 3 seconds. On line 40, we console log something. On line 42, we wait for another 2 seconds, and then at last we console log 7. So what I will do, I'll go ahead and call this main function. So I save this. And if I wrote the function correct, in 3 seconds, we should have the log and then the 7. So did you see how that worked? Let me console log again. So the way this is going to work, we will wait 3 seconds, then we will see this, just wait it for 3 seconds, console logged in the terminal. Then we will wait for another second, and we will have 7 console log in the terminal. So I'm going to save this file again to start the process. So we're waiting 3 seconds, the text 2 seconds, the number. Okay, so I hope I was able to explain how async await works. And since I feel I'm starting to lose my voice, I will stop talking, and let's consider this the end the end of the session. We'll transition to the Q&A kind of section. If you have any questions, go ahead, but remember that we will finish the call at exactly 11:55, so about 12 minutes. And if there's anyone in Erebuni meeting room right now, any one of you, I would also kindly have to ask to free the room before 12 o'clock, because there's another meeting in there at 12 o'clock. So that's it with the session. Please go ahead with your questions, like any questions, whatever it is. We have 12 minutes to discuss any questions. So go ahead.
Sanjan, you also told that if you will remember, you will talk about dot finally. So is it worth further us to read about it? Is it an important topic?
Yeah, so just let's do that really quickly. So let me comment this out. Say promise.resolve, and then 2, and say .then value console.log value, and .finally log. Now, if you recall the syntax of these try catch blocks, there is another part to this called finally. So the way try catch works, you execute your code that might return an error in your try block if there is an exception actually during the runtime. Like imagine this async function throws an error, as it actually does. We will be in this catch block. However, this finally block will always be kind of executed. So if I say console log 1 and if I comment this out, I would need to also execute this function, of course. Now, as you can see, my error was logged. So we are in the catch block because I have this text here in the terminal. So we were in the catch block, but you can also see that number 1 was logged. So we were also in the finally catch, finally block. Now, if I would also console this error in some async as you can see, 8 was logged and 1 is still logged. So again, finally the block finally is executed both if there is an error and if there is not an error. So finally always works. And in the promised land, not the promised land, but in the promised land, we also have a similar consumer called finally. So we have this .then, where we usually consume the success values. We have .catch, where we usually consume our error cases. And we also have this finally, which will always work. So regardless if the promise is resolved, regardless if the promise is rejected, this finally will always work. So the same way, we have 3 console logged, and we also have hello console logged. However, if I'm not mistaken, these finally, the arguments of this finally are empty. If I'm not mistaken, let me see. Yes, as you can see, no arguments are provided to finally. This consumer finally is usually used to to do some cleanups, right? So in case there are errors, whatever it is, to, I don't know, close some database connections, close some server connections, etc., clear some test cases, whatever it is, okay, whatever the use case is. So usually this finally is used to clean up whatever happened, and this synchronous kind of an analog of that, this finally block also kind of works that way. So very simple, not much things going on there. That's about finally.
Thank you much.
Sure. Any other questions? Anyone? Okay. In that case, let's call it a day. Yeah, I don't think I can speak for too long. So anyways, let's wrap the session up.